Hello everyone, welcome back to my channel. Now we are going to start off with the course on MCQs on electrical machines. Starting off with question. The noise resulting from vibrations of lamination set by magnetic forces is termed as, so the answer is it is hum noise. The hum is generated by magnetic field that happens due to continuous reversing of frequency of supply, or it is due to the magnetostriction. The magnetic field in the AC machine or transformers has coil which are still able to move slightly due to the vibration, and we can only reduce it by good design. Next, autotransformer makes effective saving on copper and copper losses when its transformation ratio is equal to, so the answer is it is approximately equal to 1. To quantify the saving of total quantity of copper used in autotransformer, it is expressed as a fraction of that used in two-phase winding transformer as copper in autotransformer divided by copper in two-winding transformer. So similarly, solving for this formula, we'll be getting 1 minus T2 by T1. Next, counter EMF of a DC motor helps in energy conversion. So the answer is it is C. When the motor armature continues to rotate due to the motor action, the armature conductor cut the magnetizing flux and therefore EMF are induced in them. This EMF is known as counter EMF or back EMF. And this back EMF or the counter EMF makes the DC motor a self-regulating machine. That is, it makes the DC motor to draw armature current which is just enough to develop the required load torque. Thus, it helps in energy conversion and it is always less than the applied voltage. Next, the armature of DC motor is laminated to reduce the eddy current losses. So it is C. The armature is of cylindrical or drum shape made with high grade silicon steel in form of stamping or laminations. By using the lamination, the path of eddy current is divided into several small loops and hence the area of eddy current is minimized. So the lamination is reduced. Next, width of the carbon brushes should be equal to. So the answer is it should be equal to the width of 2 to 3 commutator segments. Because with only one coil undergoing the commutation and the width of the brush equal to one segment width, the reactance voltage and hence the sparking increases as the slot width decreases. Hence, the brush width is made to cover more than one segment. However, if brush is too wide, then those coils which are away from the commutating pole zone, not coming under the influence of interpole flux and undergoing the commutation leads to more sparking. Next, rotating part of DC motor is known as, so it is known as armature. So armature is the rotating part of DC motor and it is built up in a cylindrical or drum shape and it is known as house of conductors. Next, speed of DC motor can be controlled by varying. So the answer is it is controlled by varying the applied voltage, its flux per pole, as well as the resistance of armature culture. We know that the speed of DC motor is expressed as this. So speed can be controlled by adjusting any of the three factors appearing on the right hand side of the expression. Next, EB by VT ratio of a DC motor is an indication of efficiency. So it is C. Electrical motor efficiency is defined as the ratio of mechanical power developed to the total electrical power input. In DC shunt motor, if the load is increased, the speed will reduce slightly. So the answer is it is B. Because in case of DC shunt motor, the flux per pole is considered to be constant. The torque increases with increase of load current. If the load current increases, then the armature current also increases and the speed slightly falls due to the increase in voltage drop in the armature. Next, A large series motor is never started without some mechanical load on it because otherwise it will develop excessive speed and damage itself. So, when the motor is connected across the supply mains without load, it draws small current from supply mains which flows through series field and armature. The speed tends to increase so that the back EMF may approach the applied voltage in magnitude. The increase in back EMF weakens the armature current and hence the field current. This again causes an increase in the speed and back EMF. Thus, the field continues to weaken and the speed continues to increase until the armature produces such centrifugal force that it may come out from its shaft and get damaged. Next, which of the following winding is connected in series with the armature winding of the DC machine? So the answer is both compensating as well as the commutating pole winding. Commutating pole or the interpole winding are connected in series with armature winding so that they carry full armature current and they induce an EMF in the coil, which helps the reversal of current. This EMF is proportional to armature current and ensures automatic neutralization of reactance voltage, which is also due to the armature current. The compensating pole winding are also connected in series with armature and they work outside the commutating zone. Next, the direction of rotation of DC motor is reversed by reversing the armature connection or field connection. The direction of rotation of motor can be reversed by either the armature winding or the field winding, reversing the armature or field winding. If the current through both is reversed, the motor will continue to rotate in same direction as before. Next, if the field connection of a DC shunt motor is changed, then it will run in opposite direction. If the field winding connection of DC shunt motor is changed, then it will run in the opposite direction. Next, with the increase in the speed of DC motor, the back EMF will increase but the line current falls. So according to the formula, IA is equal to Vt minus EB by Ra. In case of DC motor, the speed is directly proportional to the back EMF. So with increase in the speed, the back EMF will also increase. Therefore, the armature current is also decreased. In case of series motor, the armature current is equal to the load or line current. Next, if the back EMF in the DC motor vanishes suddenly, the motor will burn. If the back EMF vanishes suddenly, then the current flows through the armature becomes large as EB is 0. So, according to this formula, the armature current increases as very high value and suddenly large amount of heat is produced which will burn the armature winding. Next, the no load and the full load speed of a DC motor are 1400 rpm and 1200 rpm. What is the percentage regulation of motor? So percentage speed regulation is speed at no load minus speed at full load upon speed at full load into 100, and the percentage speed regulation will be 1400 minus 1200 upon 1200 into 100. So it is 16.67%. So answer is C. Next, an electric motor with a constant output power will have a torque speed characteristics in the form of rectangular hyperbola. In case of the motor, constant output EB into IA is equal to T into omega. So T into omega is constant, so the torque speed characteristic is in the form of rectangular hyperbola. So the answer is D. Next, the output power of any electrical motor is taken away from coupling mounted on the shaft. So the answer is B. The output power of any electrical motor is always taken from the coupling mounted on the shaft. Next, the output power indicated on the nameplate of any motor is always the output power of the shaft. So in case of electric motor, AC or DC, the mechanical power is always available at the shaft in horsepower written on the nameplate of the motor. Next, the speed of a DC motor is directly proportional to back EMF and inversely proportional to flux. So from the equation EB is equal to phi ZNP by 60A, the speed of a DC motor is given by speed is directly proportional to EB by phi, where N is the speed in RPM and EB is the back EMF and phi is the flux. So from the above relation we get the speed DC motor is directly proportional to the back EMF and inversely proportional to the flux. Okay, so if you like my videos, you can also subscribe to my channel, and if you have any doubt, you can always ask me in the comment section below. Thank you.